But as mentioned, again, I'm Breanne Warner. I am a solutions architect at AWS. I've been with the company for over 3 years, specifically working with healthcare customers, as well as partnering with our third-party model providers like Anthropic, Meta, Cohere. So super exciting time with generative AI and excited for our discussion today. I'll pass it to Neelam.
Hi, everybody. My name is Neelam Koshiya. I'm a principal applied AI architect. And as part of my role, what I do is everything and anything Gen AI or AI generally. And I've been with Amazon 6.5 years. My background is engineering. So in my current role, I'm marrying my two favorite things, which is data science and engineering, and building products and workloads just goes beyond POC. So looking forward to this discussion.
Okay, so as the agenda for today, we're going to do just a generative AI overview. I know probably everyone in this room knows what generative AI is, but we really want to hone in on just the complexities that we're seeing, especially in industry, and kind of bring that industry perspective working with customers, as well as some of the challenges and risks in actually emerging science that we're doing to combat some of those risks. So again, just to kind of kick things off, how many of you maybe use apps like ChatGPT, Perplexity in your everyday? Okay, I'm a huge fan of Perplexity, so just wanted to ask that. But essentially, generative AI is powered by foundational models, right, that are trained on enormous amounts of data and data that's open. So this is data that's found over the internet. A lot of those model providers, like I mentioned earlier, will train their models on also GPUs, right? So it takes a lot of compute, a lot of data, and really, frankly, a lot of money to train these large language models and foundation models. Another thing too is kind of differences between traditional AI, ML, and generative AI is that usually traditional ML is specifically designed for one use case, right? If you look at a binary classification example, or you're trying to do anomaly detection, it's very focused on one use case, whereas generative models are really entailed to actually cover multiple different use cases, right? That's really the intent of them, to cover multiple different tasks. So with that, it's really exciting, the pace of innovation. We could probably both go on and on about the really cool use cases we're working with. I support healthcare customers. They're really changing the way that providers and patients work together with Gen AI. So a lot of cool space. But as I had mentioned, the really openness of generative models and having them trained on like data over the internet definitely brings more complexity into how much control we have on that underlying data set. It's kind of not the same as traditional ML, where you have access to all that historical data and have access to that data so that you can do data cleaning and filtering. So there's a lot of new sciences and risks that come with that. But I don't want to de-emphasize kind of the economic potential of generative AI. There's been studies that have said that almost $4.4 trillion, so trillion with a T, to be added to the global economy since the boom of Gen AI. So Neelam and I get flooded almost every day with real businesses that want to use generative AI in every parts of their business. But as you can imagine, like I said, there's a lot of risk here, right? So if we take an example of a company that may have, let's say, a public chatbot on their website, or that chatbot interface with their customers. Let's say maybe that model or bot that's backed by a model comes up with a non-factual output, or what we'll call a hallucination, right? You may have heard of that term. There's a lot of things at risk here. One, that company might be non-compliant, right? Let's say that output makes this application non-compliant and they're going to have to pay some fine. There's monetary risk there. But we feel like the bigger risk is actually putting that company's reputation and brand loyalty and customer trust at risk. Specifically in healthcare, I see this all the time, where we don't want to be able to make patients scared of, oh, there's generative AI applications, they have access to my data, right? So there's a lot of risk there beyond just monetary means. And that's where kind of responsible AI comes in, right? It's kind of this theoretical concept in a way, and we'll talk about how to put this into practice when Neelam takes over. But it's really the practice of how can we maximize the benefits of generative AI, but minimize those risks? And some of the things could be mitigating bias, right? We'll talk about some of those examples as well. But that's really the idea, is the practice of developing and using models safely. So if we take a step back, and probably many of you in the room already kind of know different, machine learning techniques, extremely advanced, it seems like the audience today. But if we just take a step back and look at kind of a consumer lending model, where maybe I'm going to a bank, right? And I want to see if I should get the loan that I'm asking for, or I should not. So just, again, binary classification, it's a yes or no, I'm qualified for that loan and have the credit for that. So if we take a step back and kind of think about the things that you would consider in a binary classification, it would be things like, how is the model being trained, right? What does the data set look like? If it's looking at historical data from me, right, being a client of this consumer lending company or the bank, right, asking for the loan, maybe it would consider my historical data or my demographics. But when it comes to responsible AI, you might honestly think of things like, for my demographic group, you don't want to make a different demographic group have more false rejects, right, for that credit. You want to make sure that there's equitable components there when looking at the historical data. So really the point of this is to just show that there's complexities there when you're looking at one use case. And if you take a step back and look at now introducing generative AI, where it's actually designed to span multiple different use cases, you can imagine the mass scale of, okay, well, how are we going to detect bias if it's trained for multiple different use cases, right? Something could be considered toxic for one use case and not the other. So really just want to get y'all thinking about just the raw complexity that comes with responsible AI when we move into the generative space. So I just kind of going down this theme of assessing fairness of a large language model. Some of the things that are important to consider are kind of how the model might assume different pronouns. It's been a very common example that we like to explain to people. Specifically when talking about this example of, if you all have Perplexity or ChatGPT, feel free to test this yourself today or after the session. But we could plug in and say, you know, Dr. Hansen studied the patient's chart carefully and then. And we're showing you two examples of large language models that would output assuming the pronoun that, you know, the doctor is a man, right? Assuming he, him pronouns. So this kind of gives you a kind of a basic example of, without us sending any additional context to the model to identify, you know, different descriptions of what maybe Dr. Hansen looks like, or any other identifiers that would tell the model or give it essentially that context to know the pronouns of the doctor. It just assumes doctor, that's a man. So this is a pretty like basic example, right, to show you kind of the issues with wanting to make large language models outputs be more equitable. But you can imagine at scale, this could span beyond just identifying pronouns. It could really be kind of wanting to mitigate that risk of assuming pronouns. I'm even thinking of a medical example, right? Assuming maybe specific components of a patient, right? You don't want it to hallucinate and make up pronouns when you're not specifically identifying them. So going along with this theme, we wanted to just summarize for you all maybe the top 4 challenges that we're seeing in industry when working with generative AI, especially our customers that are building these applications. So the first one definitely has to do with veracity, right? So the factual correctness of a large language output and minimizing hallucinations. As I mentioned, you probably all have maybe experienced hallucinations working with large language models, where essentially you ask it a question, you send a query, and it's maybe making stuff up. The reason why I wanted to bring this example is, if you haven't heard of GHC, the Grace Hopper Conference, it's one of the largest women tech conferences. And if we just do another example in Perplexity, if you want to plug it in, it's what sessions are at Grace Hopper 2026. Obviously, 2026 is a year away. Grace Hopper has not released their agenda yet for the session. But if you just look at face value at this output, it kind of looks correct, right? It's calling out different workshops or, you know, emerging technologies. So at face value, this looks correct. But in actuality, this is false, right? The actual conference has not released the agenda. So just want to get you thinking about how it's super important to make sure you're cross-referencing these outputs of LLMs. And we'll talk about that in practice of how to do it as well. A few more quick challenges I want to go through too is just toxicity and safety. Toxicity is really defined by if a large language model outputs hateful speech or is excluding certain individuals or groups, right? So really harmful content that it's generating. And then of course, on the flip side, safety is really the opposite of that. It's actually producing safe outputs that make sense for that use case. But when I say make sense for that use case, it's very dependent on what the question is you're asking to the large language model and what they would consider to be toxic or not. So if you look at the first example on the left, right, and we can kind of do this thought exercise together. Should quotes that would be considered offensive be flagged by an LLM output? if they're clearly labeled as quotes, right? Or things like opinions, right? If you hear it at face value, not knowing its opinion, that might be seen as offensive for some use cases. But for others, if you clearly define it as an opinion, maybe that would be considered a safe output. I see this mostly also, again, in the working with healthcare customers, where maybe you need to tell the large language model, hey, you're going to give patient information or maybe patient advice on how to sign up for a blood test or maybe build an agentic workflow there. But you want to exclude giving medical advice, right? The AI is not a doctor. So you want to make sure you're creating that safe output by putting a guardrail on. And Neelam will talk about how to make those guardrails as well. And then the last few I want to focus on is I've kind of given you examples of text generation, which you probably are all very familiar with using those applications I mentioned. But what about image generation models, right? Or video generation models that have become very popular from providers like Loom AI, Stability AI, right? Intellectual property comes into question. So if you kind of think about it, right, these foundation models are trained on the open data, right, over the internet. And this can include things like Picasso's past work or Andy Warhol images. And early stages of these generative models would almost regurgitate exact copies if you were to ask it kind of a query like you see at the end. And let's think about it, right? If these artists were alive today and in the court of law, who would own that intellectual property, right? Who would be responsible to actually own that ownership of this image, right? So just kind of getting you all thinking about how our customers that we work with need to make sure that they're protecting their businesses if they're using things like image generation models. And ways they do that with also model providers is indemnity, right? Indemnity clauses are pretty common with model providers where they will essentially say, or even cloud providers do this too, where we'll protect you for, if you use the models through these APIs, we'll go ahead and protect you from intellectual property claims. So these are just things to look out for. It's really the legal AI policy, right, between working with generative models. But I also just want to ask the audience, if you just look face value at this image, how many of you think this is like a photograph, like someone took this picture? Okay, how many think AI? Okay, I guess it's a trick question because we're at an AI conversation today. But yeah, this was generated by an image generation model. And I wanted to do that exercise because at face value, you can't really tell that this is generated by AI, right? And the models are getting so much more impressive. It's almost like every day a new model comes out that's beating the next. And as they get smarter, it's important to be able to add what we call a watermark to actually identify that this was generated by AI. How you do that, there's lots of ways to do that, like basically making the digital fingerprint for this image, like doing invisible embeddings on the back end. And Neelam will kind of talk about different ways to do that as well. But just to kind of wrap this up, right, there's a lot of different challenges, but there's a lot of interesting science that has emerged to actually mitigate some of these challenges. Some of them we've already talked about, like how can we mitigate bias in the training data? There's also things called guardrail models, if you haven't heard of them, which Meta has one called Llama Guard, which essentially is a specialized model that can do content filtering at inference. So you can set a guardrail to say things like, don't give medical advice in your answer, things like that. There's also model disgorgement and machine unlearning. So basically, if you look at a model that's already trained, right, an LLM that maybe you've already played with, and you want to take specific data and basically take away that influence from the model, but not change that model's knowledge. So what do I mean by that is basically if there's bias in that training data and you want to remove that influence from the actual model without having to retrain the model, because as we all know, money, GPU time, and lots of data. And then just to like finalize on the bottom three, we already covered watermarking, but I think red teaming is interesting to mention to you all. Red teaming kind of goes now beyond just penetration testing. It goes into kind of creating an AI hacker team, right? To essentially say, how can we test this model to its limits to actually find the vulnerabilities, right? What are ways that we can essentially break the LLM to then get to vulnerability outputs? And then you can then put a guardrail, right? So these emerging sciences can also work together. So I've spoken a lot around the theoretical components of responsible AI, just kind of things to be aware of in this space. And now Neelam's kind of going to talk about how these 8 different tenets of responsible AI can be put in practice.
Okay. So thank you so much, Breanne. So we covered the what, we covered the why, and now we're going to talk about how. How can we implement responsible AI as part of your life cycle? And these are core 8 tenets. And for each of these tenets, I'm going to show you an example of how you can help inculcate that as part of your work. So first of all, I'm going to talk about foundations, right? How many of you know about NIST, National Institute of Standard and Technology? I see one hand, second, third, fourth. Okay, so folks in this room know about it, but I just want to talk about NIST specifically for responsible AI. So NIST is a framework which is being coined under the US Department of Commerce. And some of the things that they take into consideration is cybersecurity, any types of compliances, and responsible AI is another piece of it. And they came out with this responsible risk management framework. What it actually does is it will tell you to educate within your own teams and organization what the risk is. And this is the formula that they provide. Nothing fancy about it. Basically, it talks about the measure of events probability of it happening into the magnitude. When I say magnitude, it means the blast radius when something like this happens. Show of hands, how many of you know about what happened with the airline in Canada when it's hallucinated and it was like a big lawsuit that happened? Do you know about it? I think, just Google it after this session. For a lot of my customers and Breanne's customers, I think we talked about the trust is the brand of the customer is big, big, big deal, right? I lose money, I can gain it back easily. But if I lose my brand and my perception of my brand and the customers start losing trust on my brand, I think that's the biggest risk. And what NIST is trying to do is help you for these use cases that you're going to build using GenAI, help you to assess the risk and guide you through the process of how to think through it. So first is to educate everybody what actually is the risk. Then you figure out what's my use case, identify any potential harmful events that can happen, like this chatbot hallucinating out, in the public. Because remember, it's an open-endedness, right? Anybody can type in anything in that chatbot. So how are you going to control the output that you get is the biggest point, right here. And then summarize the different risk levels. So how do you summarize the risk? So here I have an example matrix, right? I have the likelihood of that even happening. For example, my chatbot hallucinating out there. And how severe would it be, right? And then you show this to your stakeholders saying, based on your use case, based on your risk assessment, this is the matrix, and you might be in the red, and you might have to mitigate these risks or figure out a way of how you can do that. And the framework has first part, which is educating, and the second part is this formula. So they say that map, measure, and manage. It's kind of a flywheel, and you kind of govern through and through. Now, this is very theoretical. How do we make it practical, right? So if you look at any project, right, you would have a use case. So you see the use case, and you might have some objective matrix like accuracy, latency, some non-functional requirement like uptime. It needs to be on 24/7, for example, right? So you see the middle box over here. All the projects that you work on most likely would have that. When we talk about responsible AI, we think that it should not be just a science, which we talk about, we like it, we believe in it, but the way to materialize it is to think about responsible AI as a part of your product management. So you have to have some kind of foundational guidance or principle, which you set within your organization. Hey, we believe in sustainability, we believe in human rights, and so on and so forth. And that can be your most foundational value. And on the top, we have all the 8 tenets as a guiding force across the board when you evaluate or you go through your product management lifecycle. Now, I think the first thing a lot of customers ask us is, okay, how do we get started with it? So I think we can have intentions, that's great, but we need to have some kind of mechanism. And one of the ways that we feel is to start off by writing a AI policy. Hey, this is my policy. These are my rubrics, and publish it across your organization saying, every time you build any project which has AI in it, you want to make sure that you keep in mind the guidelines, the standards, the framework, across the board. And a lot of the customers that I work with have something called as Cloud Center of Excellence. Have you heard of Center of Excellence? Let's just say Center of Excellence. Have you heard about Center of Excellence? Okay, I see a few nods, but Center of Excellence is a group of principal engineers or principal advisors. For a lot of these big customers or enterprises, anytime there's a use case, they go and approach the principal advisors or engineers saying, this is my business use case. This is the architecture I'm thinking. Help me, see through it. Is it good? Is it bad? What are the loopholes? Is there any security concern? Is there any risk, etc. Right? If you have an AI policy and you have the Center of Excellence, you embed it as part of it, one check that you can have when you're building any project could be, is this project in line with the responsible AI policy that my organization has set? And it can be as simple as none of the Gen AI should hallucinate or should have guardrails against toxicity. Very, very simple, human understandable, line items on the policy. The next step is the use case. So you want to select a use case which you can do the risk assessment, figure out if I don't have the way to manage the risk, is it worth investing in? So that's another way you can, shorten the list of the projects that you want to work on based on the rubric as well as the risk management. Now we're going to start off with the first one, which talks about fairness. So fairness goes hand in hand with bias as well. You did see the example which Breanne showcased, and I'll talk to you as to how we can mitigate that example, wherein Dr. Hansen was looking at the chart carefully, and both the LLM said how can we go about that? But in pure words, in terms of the definition, it is just a way for us to not have bias and build systems which are foundationally fair. And one of the ways you can think of, and this is a screenshot from one of the products that we have, which is called a SageMaker Clarify. But one of the ways that you can think of it, you build a model or you build a system, you evaluate it. You evaluate it for F1 score, recall, accuracy. Is it in line with the business? Does the response look good? But what we ask customers is evaluate it for bias. Make sure you have the output matrix like you have over here, like class imbalance. You can have, other matrix like JS, etc. So it should not be just, I have F1 score or root mean square. It looks great. Let's go for it. But you should also think about what are the biases in my model? Or is there a bias in my data set? And this is not just for Gen AI, but also for traditional machine learning models that you might be building. Now, the question that she had, and I think I did a spell mistake, but you get the idea, right? So I said, Dr. Hansen having a beard. So I'm giving it more context, instead of just saying carefully looking at the chart. One of the ways that we ask our customers to build application is to provide more context to the model. So it has all the context and the knowledge to then provide you the proper response. And if you look at models, right, they're open-ended, right? You go into ChatGPT or any of your favorite LLM and type into it, write me a story about a pony, right? And it will write you a story. It is open-endedness. So a lot of the customers struggle with it not being deterministic. Hey, every time I ask it to write a poem, I get 5 different options, different times, different instances, I get 5 different versions of the poem. Why is that? Well, the foundational feature of a foundation model or a Gen AI application is exactly that. It is an open-ended. And that's the reason why, it can be used for so many different use cases, right? So with like her slide, with in Spider-Man word, with, a lot of strength comes a lot of responsibility, right? So even in our, Gen AI models, it has a lot of power, but it comes with responsibility. So here's me playing with it, right? So I asked it having a beer, and you can see the first time, maybe the model was good and it said she, and then I said, why are they assuming it's a she, right? And then I asked saying that, Dr. Hansen having a beer, and then it's, go back to he. The inference that I want to draw out of this thought experiment is that the more context you provide, the more fair it could be, the more you can tune it. Okay. Now, this is another, exercise that I have. Okay, who are better drivers, men or women, right? And this is a plain response from one of the models, right? Even though you might find it funny, it's very sarcastic, however you want to word it, in the way we measure bias and stereotyping in science, in the data science world, anybody can, spot this response as a good response, right? It can say, okay, I'm not going to make biases, and gender is not an indicator of a driving skill. So a lot of these models are built in such a way, especially the newer generation of the models. If you see like the older ChatGPT versus the newer one, right, you can see the evolution over the period of time. And a lot of the newer models will have these guardrails built in to the model itself, wherein it will try to avoid, stereotyping. Now, the next one is explainability. I think this is the most important one, right? You answered me this. Explain me, how did you come to this conclusion? And it's not as simple as you go to one of the LLM and ask it how many R's are there in a strawberry. I think that's a very popular one wherein it kind of hallucinates, is not able to find out the exact amount of the count of R in the word strawberry. But it is basically lack of a proper explanation of the behavior and outcome. So remember, the one of the biggest tenet of responsible AI is auditability and governance. Why did you say the way you said it? What made you come to this conclusion? And why did you answer the way you answered, right? That is what explainability is. So I have an example here, right? I provide it the context, right? And I ask it, based on that, here are the options. Which option do you think is the correct one, right? And it says, no, it doesn't match with any of the option, and it matches with other because it's about the product usage question. And then it provides me an explanation. So when we are working with customers using patterns like plain prompt engineering, what's really happening is the number one thing that we do is, okay, sure, you get me what was the sentiment of the customer. It was negative, neutral, positive. I'm just giving you an example. But why did you say it is neutral? What made you say it is neutral? What is your confidence score? So in addition to get just the plain answer to your question, we also make it respond back saying, provide me the explanation, the reason for why you said what you said, and how confident are you that it was a positive sentiment. So that, all of that is the way you design it. And one of the biggest way of designing it is, doing a prompt engineering, something like this. Okay, this is a really busy slide, but what I want to draw, and these are like real logs of one of the experiment that I did. Okay, how many of you are familiar with agents? Okay, cool. So for folks who don't know about agents, agents is a multi-step orchestration. So imagine you go to ChatGPT. Let's take an example of ChatGPT. You go to ChatGPT and ask it, which is the best hotel to stay in Hawaii in the first week of August, on so and so island within the budget of say $1,000 for 5 days. I'm just making it up, right? And it will maybe serve the internet, give you the response. But I say, why don't you book it? I like the option number one, book it for me. Do you think it can do it? So I think one of the biggest use case of agent that we see is going beyond just Q&A, making the AI do the task for you. Instead of you going to the first link that it provides, like Kayak, for example, and you have to click, 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 and go through and book it. A lot of the customers are, the new age of Gen AI is going to be agentic, wherein I'm going to be in one spot, I want to buy 100 stocks of Amazon, for example. I'm just making it up, right? And it knows my credit card. It knows this is Neelam, it knows all the details. Boom, it's, bought it. I don't have to do any clicking, right? So those are some of the use cases of agent, right? Now, with this fantastic product of agent like multi-step orchestration comes a bigger issue. How did you think? How did you come to this conclusion? How did you answer me the way you answered me, right? So here I have an agent which does energy, like an electricity, agent, wherein it does energy forecasting, right? My question for this one was, can you give me my forecasted energy consumption? How does it compare with my past energy usage and my customer IDs one? Okay. So you can see the first line of that. It says step one. So it does something called as react or chain of thought, like the way the prompt engineering works. So first step it says, that to answer this question, I'm going to do three things. First, get the forecasted consumption for the next 3 months, retrieve the historical consumption, compare both of those simultaneously, and answer the question. And then it uses these different tools, right? LLM doesn't have access to, it has access to the Wikipedias of the world, but it doesn't have access to your specific system, like your databases, your APIs, etc. And tools are exactly that, your APIs, which the LLM has access to. So when a question comes like this, tell me about how am my usage looking like? It knows, okay, I need to use this tool in which I'm using the tool to get forecasted consumption. I'm getting the current consumption and I'm comparing and I'm providing the response. So you can see the entire trace of the steps that the LLM took or the agent took to come to this conclusion. Now, why am I showing you this, right? Number one, it helps you to explain, provide the explainability of how did I come to this conclusion. Tomorrow, if you have a chatbot which helps you to book tickets, right? And a customer comes to you, hey, it was wrong, it didn't do correctly, I was charged wrongly, etc. In the court of law, right? You can pull out all these audit log explanation of, hey, this is what happened. You confirm, let's buy it. And that's why I bought it, etc., etc. So the whole goal of explainability is not only just plain, hey, to understand how the LLM is thinking, but for you to safeguard against any kind of issues that might crop up later. Okay, so next up is the privacy and security. How many of you read the privacy policy for ChatGPT, for example, or any of the LLMs? Do you think they're using your PII data, whatever you share? Do you think they're using it? So I would say, take a close look. Every time you use any of the LLM, like the open, the chatbots out there, take a look at their privacy policy. Most of the free ones, are free for a reason. So, pay close attention to that. But when I talk about privacy and security, I think the number one is when we talk to a customer, will my data be shared with a third-party model provider? Will it be shared with Anthropic? Will Anthropic use that data to build a new model? I think that's the number one question. And that's the same question you should ask as well. The number two question is the data that I ask, like, hey, I want to book this ticket for Hawaii, etc. Will that data stay within my own account? Or will it be, if you have multi-tenant users, will it be shared as well? I think that's the second question that you have to ask. The third is, will the data be encrypted in transit or at rest? That's the third question you would have to ask. And then the logging and monitoring, I think we talked about it, but just making sure that you are having the auditability or the tracing, I think that's another one. And then the compliance, GDPR, PCI, HIPAA, all of those compliances are another thing that you would want to think of. And when you're building a project or a GenAI application, you want to think through all of this and have a checkbox, a checklist. Okay, yes, this is true, this is true, this is true. But these are some of the common denomination when we look at privacy and security. Okay, so here is the fun stuff. Okay, so you look on the left side, you can see the prompt. Okay, so I'm asking. There is a discussion that has happened, right? And there is a between an agent and the customer, and there are some PII information that the model pulled out from the backend. And PII information like the name of the person, which is Jane Doe, the email ID of the person, the booking ID can be also PII or private data, maybe like customer IDs or PII or private data in different organization. And you can see why the model responded back with all that PII data. The user in the end did not see the name, did not see the email, did not see the booking ID, but did see the like the rest of the response, right? So basically, one of the mechanism, like Breanne talked about, is a concept of guardrail model. So I think there are a lot of papers out there, but the concept of guardrail model is to have that first line of defense, which would help you to safeguard against PII, masking, prompt injection, jailbreaking, make sure that you stay on topic, make sure that you don't deviate and share information which you are not supposed to be shared, and then prevent hallucination. So I do have different examples when I go along the, as we go along the slide, but I'm using one of the guardrails, service, which is our own Amazon's product, which is called as AWS Bedrock Guardrail. I don't have a title, etc. I just wanted to show you an example, but you can, get the picture of what a guardrail would do. And the next one I'm going to talk about is transparency. So being transparent or providing enough information to your stakeholders and making sure that you are making use of AI in the right way. And when I talk about transparency, I think you'll get more clarity by looking at the following slides, right? Has anybody seen a model card of Claude, OpenAI, Llama? Okay, I see few heads nodding, but basically, even when you are, starting off with a project and you're thinking, I'm going to try Llama, Mistral, and Claude model, for example, right? I think the first thing you should do, even before looking at the, the leaderboard, etc., is to go to their model card. And here is a screenshot of the PDF file of the older version of the Claude 3 family. And you can look at the model card and you can get a lot of the information, whether you should be using this model or not. So the first one is the users. What are the intended users? What are the unintended users? What are the prohibited users? You should not use it. What are the limitation of the model? How was it trained? What is the methodology used? You can get all of that from just reading at the model card. Now, for some of the open source model, like the Llama models or the Mistral model, you can also go in deeper because they're open source. You can play around, you can pull the layers out, etc. as well. And because of that, we see a lot of customers, especially in startup or a regulated industry, sometimes want to use open source because they know exactly the layers. They can freeze the layers, they can fine tune based on their use cases. So that's the reason why we see a lot of adoption for the Llama family, the Mistral family. Okay, so here is the kind of a smaller excerpt of the paper. You can see the intended use says honest, helpful, honest, harmful assistant for open-ended conversation and collaboration on ideas. You can see the unintended use says, it can support a lawyer or a doctor, but you need a human in the loop. So if you have a use case wherein you build a bot which provides legal advice or medical advice, you cannot use a Claude model for it because that's not the intended use for it. If it is internal, maybe a doctor take a look at it before it's been sent, sure, you can use it. But I think this is something that a lot of people don't even know about. Hey, there's information like this in a model car. That's kind of worth checking. And then you can also see the limitation. What is the limitation? It's not multilingual, doesn't support certain languages, etc. And then the other key pieces that I want to talk about is how did this model do against the toxicity data set, right? So a lot of the times when a model provider launches a model, it will provide a nice dashboard of comparison between the famous data sets and how did it do against it. One of the ones that kind of gets overlooked is the toxic responses. So I don't know if you're familiar with Wildchat, but it's a data set in Hugging Face. For a lot of the model providers use it for testing the toxicity. And you can see in the paper how Anthropic Claude models or the three family did against that data set, how did it do against the bias benchmark for QA, etc. So that's something that you should take a look and have transparency about. Because remember, you're going to use this model, build the systems, or maybe you're building the model yourself. You might have to disclose all of this information as part of your product release. So that's another thing to think about. Okay, show of hand, is this picture real or is generated by AI? Is this picture clicked by somebody or generated by AI? Okay, everybody's paying attention, cool. It was just a trick question, but I think Breanne touched on watermarking. A lot of the government customers that we have or other customers who are using large language models to create avatars or personalized marketing campaigns, etc. I think one of the biggest asks is how can I tag the images that are generated are really generated by an LLM versus a person actually taking that picture, right? And one of the ways that we think and we provide is, a lot of the model provides is the watermark. So if you cannot really see the watermark here, but if I upload this picture and check using one of the, is there a watermark API, you can see the content credential says that yes, it was created by AWS and this is the model it was used. And then this is when it was issued, like when the watermark was created. So this can be a really um, powerful tool in the world of deep fakes and AI, etc., where you can provide transparency to your own consumers who are using all of these products, saying, hey, by the way, even though it looks very realistic and you can use it for whatever use case you have, if there is a point wherein we have to justify whether this is generated by AI or not, we can have the watermark for that. Okay, next up I'm going to talk about is controllability. So controllability is to make sure that you are able to monitor and steer the AI in the right direction. How many of you have heard about MCP, Model Context Protocol, or tried out? Okay, it's the newer buzz that's happening. But basically, the concept of MCP is you have a server, an MCP server, and an MCP host, and there's a protocol called as MCP protocol. And the protocol, you don't really need to worry about the schemas, which APIs to use. You just get the toolkit and you can just connect to it via a CLI or any kind of a MCP client or a host, as we call it. So the below screenshot over here, I connected the MCP provided by PayPal. People know PayPal. They are one of the currency whatever transactional provider. Okay, and there is another one you can go live and you can go online and check. Stripe also has this agent tool. Okay, and I start playing around with it. I don't have a real. I'm not a merchant. I don't have a business, but I created a developer account. I downloaded the agent kit. I hosted the MCP server. I used my client to connect to the MCP server, and I'm able to do everything. I'm able to create invoices, list invoices, and this is a dev account, but you get the idea by few clicks. And it's just a queue chat. So I can just ask it, tell me what invoices are there. And it will just provide me the response, right? Based on my, of course, I'm passing my credentials, etc. But you get the idea. But how about this, right? Do you allow, so for example, I want to create this invoice, right? You see the last slide over here? It says, allow this action. Do you give me the authority to create this invoice on your behalf? And it provides me the option of yes, no, or trust, right? And I say T, if I say T, then it will actually go and create. If I say no, then it will stop. It will abort at that stage itself. And that is controllability. Even though maybe you build a AI project wherein you want to make sure it's read-only, and maybe you can do right for certain use cases, and for some you don't. You want to have a way wherein you can control the AI. And that's the example in the bottom. And the other one is an example for a control for an agent, wherein the agent, you empower the agent to make sure that the user confirm. You can ask additional questions to make sure that the actions that are performed are in line with what the user really wants. So basically having these knobs, as we call it, to make sure you are controlling and steering the AI in the direction that it's supposed to really go in. Okay, and these are the last ones. I'm going to take safety, veracity, or hallucination and governance all together. I think they are pretty self-explanatory, and I'll showcase some examples, along the way. So I'm going to take the safety first, right? What do you think of this question? And what do you think of this answer? Right? So there are no guardrails here. It is just the model's inbuilt nature, wherein it's able to detect, this is not safe, right? This is not really safe use of AI, and is able to prompt back, with a response that is, right. But what I want to draw conclusion out of this slide is that a lot of the models have some of those inbuilt guardrails to help you make sure that it is safe or not, right? So that's the number one point. Number 2 point, sometimes what you consider safe for your use case might not be something that the model might consider safe. In those use cases, you might have to have a guardrail. So this is an example where I have a guardrail in front of an LLM, and it's able to, and this is like a multimodal use case. So there is an image, and I don't have the image for obvious reasons, but it was able to, so guardrail was able to detect that there are some insults in the image. And if you look at the guardrail action, it says that, I'm not going to work with this, whatever this question is, etc. And we say, sorry, the model cannot answer this question. So you are stopping the AI system from, restricting it to respond back to this question, which might not be safe for your audience or for your use case. Okay, so this is a fun one too. If you look at a banking assistant, something which would check, how much money you have in checkings, or create a new credit card account, or get a new credit card, and you ask a question, should I open a credit card account? And you can see the model response back, and it is, all good. The chatbot was supposed to do this. It is a banking assistant. Open a credit card falls into that category. Cool. It's all good. And you can see bottom, it's passed. Guardrails didn't really intervene. But how about this? I asked it, should I invest in stocks? And you see the response from the model. The model doesn't know what is your use case. You're just a banking assistant. Maybe investing in stocks might be something that is in purview of banking assistant according to the model, maybe not, but you know your application better. And so within the guardrails, you can say denied topic. And this can be against your competitors or any other topic that you don't want the model to deviate from. And then you can see, even though the model responded saying, risk tolerance, everything about the stocks, the final response which the user saw was, sorry, I cannot comment on that. So that can be another place where you might have to use guardrails to control, to make sure that your application is safe. Okay, the last one, and I don't have an example for it, but it's for hallucination. How many of you know RAG, retrieval augmented generation? Okay, few hands. But retrieval augmented generation. So if you look at a model, right? A model is trained on the Wikipedia of the world, right? But there is a cutoff. So, for example, the latest Claude models have a cutoff of April 2024, for example, right? After April 2024, if you ask who won the World Cup for so-and-so, if the event happened, for example, in September, they might not know, they might hallucinate. Maybe they might come up with a response of, the prior year who won that World Cup. And that's a big problem. In order to overcome that cutoff issue with large language model, what we do is we provide them with data of the latest data set, right? Whatever is the knowledge corpus, as we call it, of the latest data set. And this is just an example, but you can think of, your business specific domains or your in-house data, etc., right? And you give the model the context of all of this knowledge corpus. You create embedding, and then you feed it so that the model is empowered with all the latest and correct, accurate context to provide the inference to you. And the Canada airline use case, where it hallucinated like crazily. For those use cases, a lot of the times when you do evaluation for your RAG-based workloads, you would check two things. One, the contextual grounding and relevance. Basically, is your response or is the LLM response in line with your knowledge corpus? Is it grounded in that knowledge corpus? And that's actually a data science matrix. And there are guardrails who can, where you can check, you can put a threshold saying that, oh, right over here, right? 0.7% is my threshold for grounding. And, like 0.7% is my threshold for relevance. So you can fill, if you have a RAG application or summarization, wherein you're summarizing a huge, giant text, etc., you can, go away with it. So that's, you can think of the way to encumber the hallucination using guardrails as well. Okay, cool. I think I'm like maybe 2 more minutes. I think intentions are good, but I think you truly need a mechanism. And the way you can think about it is build awareness, establish foundation, expand the capabilities, and then integrate it into the operations. Most of the people I work with are LLM consumers. So this is kind of the call to action for LLM consumers, evaluate, engage, have those 8 tenets in mind, evaluate the risk, monitor, iterate, and then just think everything responsibility as part of the product management. And then this is for the providers, think of what is the algorithm you're picking? what is the data set you're picking? What is the technique? How does it hold against toxicity data set, etc.? And then be transparent of, all the data like you provide in the model card. And not all the LLM providers, in full honesty, are very transparent. Some are, some are not. So I think that's another thing that the LLM providers should do better. Okay, thank you.